In this video, we will look into the classic problem, trapping rainwater problem. So what's the trapping rainwater problem? So you will be given an array of numbers. You will be given an array of integers, each indicating the height of the walls, and you need to find out how much water, how many units of water will be trapped between those walls. If you look into the picture here, this picture will hold 6 units of water. 1 unit over here, 1 unit over here, 2 units over here, and 1 unit over here, and 1 unit over here. Totally, it will capture 6 units of water. If you closely look here, the amount of water that can be stored between two walls is finding out the minimum of the two walls from the left and the right, and subtracting the existing value from the minimum of the two values. If you see the first here, see the height of the wall on the right side is 2, and the height of the wall on the left side is 1, and the height of the current wall is 0. So the minimum of these two is 1, and 1 minus 0 is 1. So the unit that can be holded here is 1 unit. Similarly, if you see here, the maximum height of the right side of the wall is 3, and the maximum height of the left side of the wall is 2. The height of the wall at index 4 is 1. So the minimum is 2 and minus 1 is 1. So if you look closely, what we need to do is we need to find the maximum height on the right side of the index and the maximum height on the left side of the index, find the minimum of two values and subtract it from the existing value. Operations we need to perform is to find the max to the right of the current index, to find the max to the left of the current index, find the minimum of max left and max right of the current index, and then add the difference to the total. Find the minimum of the max left and max right and delete it from the existing value. You can see in this picture what I am talking about. So given an array of index 0, 2, 1, 3, 1, 3, these are the height of the walls at that particular index. The first index will be 0, the second index will be 2, 1, 3, 1, and 3. So if you want to find how many units at this index is stored, we need to find max left array that we are going to generate. If you see this, the max left, there are no elements to the left, so the max will be the value of that particular index. So if you want to find the max left of the index 1, we need to find the max of the elements to the left, including the existing element. Similarly going on, and we need to find out the right max array for each index. We will take the example of index 0. So the max of 0 on the left side is 0, and the max of right side will be 3. So the minimum of both is 0, and 0 subtracting the existing index value 0 is 0. We will take the index 2. The max to the left is 0, and the max to the right is 3, and again the difference here will be negative. 0 minus 2 will be minus 2. Again, you can't hold any value here, you can't hold any water at this particular index. The max left and the index 1 is 2, and the max right is 3. The minimum of both is 2, and subtracting 1 from 2 gives the 1. So you can hold 1 unit of water at index 1, and if you go on, you can hold 2 units of water at index 5, and the total amount of water would be 2 plus 1, 3 units of water you can hold. So we'll go back to Leetcode and solve this problem. So I'm here on my Leetcode. It's the same example I have shown, the same input which holds 6 units of water. So now we'll go ahead and solve this. Like we talked earlier, we need to have two different arrays. One array storing the left max and the other array storing the right max. So let's go ahead and create those functions of left max and right max before doing anything here. So this function will generate an array having the left max of each index taking the height array that's provided here. Similarly, we will have a right max function. Alright, so how do you find the left max? So left max shown earlier, we need to find the left max at each particular index. I will initialize a variable called max, which is the first element, and then I will loop the array and find the maximum at that particular index. So I will only loop once, it will be order of n, time complexity. I have written my left max function. What it's doing is, initially I am assigning the first value height of value at index 0 to the max value, and I am looping through the array height array, and I am checking for each index if the height of I is greater than max or not. If it is not, I am assigning the max value to the current index, and if height of I is greater than the max value, I'm assigning the height of y value for the index and assigning the height of y value to the max variable so that the max holds the latest greater value. Similarly, we will find out the right max. Right max is similar to left max, except that we will do it from the back, from index of height dot length minus 1 to index 0. Here in the right max function, we are doing the same thing like left max, except that we are doing it from the back. For the right max, we are starting with the last index and finding the max value there and looping back to index 0, and we are doing the same thing. We are assigning the max value to that particular index if max is greater than that height of I, or if height of I is greater than max, we are assigning the height of I value to the particular index in that right max array, and similarly we are reassigning max to height of I. So now we have this left max and right max functions ready. Let's go ahead and create a left max and right max function here and call these functions. Let's go ahead and create a left max and right max array and call this function to populate those arrays. But first, what I will do is I will have array length variable so that I don't want to do this height dot length all the time. The initial total is equal to 0. This is basically units of water, so water it can store. So have that. And the other thing, let's say if the given array length is less than 2, that means if it has only 1 bar, it can't hold any water, so I would just return the total. I don't want to do any computations if the array length is less than 2. Just return total. Now we will populate the left max array and the right max array. We will initialize the array first. We have initialized both of the arrays. Now we will populate them. We will pass the empty array and the input height array. Alright, we will do the same thing with the right max array. Now we got both the left max and right max sorted out. Now what we need to do? We need to take in the height array, the input array, and for each index we will find what amount of water it can store at each index. For that, we have looked into the amount of water that can store at each index is finding the minimum of left max and right max at that particular index and subtracting the current index value with the minimum of left max and right max. So let's go ahead and do it. If left max array of I is less than or equal to right max array of I and left max array of I value should be greater than height of I, or else we will be getting a negative value let's say if the left max array index of I value is 2 and the height of the current index is 3, that means it can't store any value at that negative index. We'll check both of it and we will add the total, the units of water it can store at this particular index is max array of I minus height of I. That is the total of amount of water that it can store at that particular index, but we want to add that to our units of water that needs to be added every time for all the indexes so that we get the total amount of water it can store. So we'll add that to this plus equal to this one. That's good. Or else we want to check the same thing with the right max array. Just copy. Okay. It's greater than right max array. And similar to the above, the height of the right max should be greater than the value at the current index of height, so that we don't get a negative value when we subtracted. We will do the same thing, except that we'll be subtracting height from right max value. All right, we are almost there, and finally we will return the units of water value. That is it. So just to walk through, so let's see how much time it is actually taking to compute all this. We have iterated the function, iterated the array 3 times. Once at the left max, once at the right max, and once in the trap function. That is 3 into n. Since 3 is a constant, this would be order of n time complexity. And since we had initialized 2 new arrays, that means we are taking extra space, so it's order of n. So let's go ahead and run. The time complexity here is order of n and the space complexity is order of n. I'll go ahead and run this and see how the output would be. Looks like we missed some semicolon somewhere. Oh yeah. Alrighty. Somewhere I am returning total at line 5. Oh, my bad, it's unit of water. Alright, it is successful for one test case. Let's go ahead and submit and see if it will be successful for all the test cases. Right, looks like it got passed for all the test cases and the runtime is 2 milliseconds. I did solve it the other day, but the runtime was 4 milliseconds at the time. I was doing an order of n square time complexity at the time. So this is a little bit better. We did it in order of n time complexity and order of n space complexity. In the coming video, we will look into see if we can make it much better with the order of n time complexity and order of 1 space complexity without initializing the new arrays. I hope this helps. Thank you.